Precision farming in root crops presented through completely original drawings. Cassava root crops are cylindrical and tapered, with a firm white or yellowish flesh beneath its rough brown skin. Dasheen or taro roots are round, oblong, or cylindrical in shape, white on the inside with a hairy outer layer. Potatoes exist in about 100 varieties, ranging in size, shape, color, flavor, and starch content. The skin may be smooth or rough, while the flesh is yellow or white. Edo's or Tania is a relative to the Dasheen roots, but is smaller and more round in size and shape. The flesh has a sticky consistency and may be white, pink, or yellow. There are also many cultivars of sweet potato with a variety of different physical characteristics. Finally, yams are roughly cylindrical in shape with brown skin and a firm white or yellow flesh. With their complex carbohydrates and low glycemic indices, ground provisions provide sustained energy release for longer periods of time. They also provide fiber, protein, vitamins A, C, B6, and beta-carotene, and minerals iron, calcium, potassium, copper, and manganese. Physical and mental health benefits to eating root vegetables come from their high amounts of antioxidants. Sweet potatoes originated in Central America. Potato originated in the Andes mountain of South America. Cassava is believed to have been initially cultivated in Brazil. White and yellow yam is indigenous to West Africa. Edos were developed as a crop in China and Japan. Dasheen originated in Malaysia and India. Ideal growing conditions include full sunlight, well-drained sandy clay loams, temperatures of 35 to 32 degrees Celsius, and a pH of 5.5 to 6.5. Planting methods include cuttings, vine slips, small tubers, stakes, trellising, mounds, and ridges. Because cassava production increased, sweet potato has fluctuated and yam cultivation remains low. This is the current situation and seeks to reduce the cost of imported carbohydrates. There is a market for value-added products. Some of the problems the industry faces include high transportation costs due to weight of provision, high labor requirements in planting and harvesting, problems of storing highly perishable goods. Some people may not prefer the taste. Climate as a limitation to production, and farmers have little access to land and financing.
Precision farming is defined as an information technology-based, relatively better management system that identifies, procures, analyzes, and manages natural variability amongst the fields and optimizes productivity, profitability, and sustainability, which protects the land resources. The key to precision farming is management. By using yield monitoring, the crop yield and field position during a harvest can be acquired. This information is then put into a personal computer where soil analysis takes place and yield maps are produced. These yield maps can then be used to create prescription maps that tell the farmer which part of the field requires specific management. This makes cultivation and seeding easier for the farmer, which saves time and money. The GPS can automatically guide the farm machines in the field, and with little input from the farmer, these machines can cultivate, seed, and fertilize the field with a very high accuracy. The process is repeated, and by logging data each time, farmers can make better management practices in future applications. This process can be applied to root crops to obtain all of the benefits it entails. Remote sensing is the use of sensors that measure the characteristics of the field without having any contact with the characteristic being sensed. Some types include aerial photographs and satellite imagery, which are all non-intrusive sensing methods. Remote sensing can measure things such as vegetation stress, fraction of vegetative cover, green leaf index, and chlorophyll content. Kriging is a statistical method of smoothing or averaging georeference data points of unknown data to create class post maps that are classified according to data properties. Class post maps identify different ranges of data by automatically assigning a different symbol to each data range. Grid sampling breaks the field into square grids that generally range from 1 to 2.5 acres, highlighting differences and making it easier for farmers to make proper farming decisions that saves costs and preserves the environment. By looking at differences in the field, farmers can easily assess which portions require specific management needs. The variable rate controller regulates the appropriate chemicals to use on the application maps. It refers to the application equipment that includes controllers used to vary fertilizer, pesticide, and lime outputs as prescribed by an on-the-go sensor. Precision farming differs from traditional farming in ways such as nutrient management application methods, plant protection treatment methods, mechanization, arrangement of plants into homogeneous blocks, data influence management decisions, and in subdividing a field site into heterogeneous areas.
Advantages of precision farming include reduced fertilizer costs and use, reduced pollution through poor use of chemicals, and improved crop yields.
GPS allows for easy surveying and plot division.
Disadvantages of precision farming include it may require specialist advice, initial capital costs may be high, it may take years to collect sufficient data. Collection and analysis of data may be tedious, and there may be errors in data collection and analytical software. Recommendations and solutions to these disadvantages include providing efficient and easy data managing systems, education of farmers on basic techniques, and the subsidizing of equipment and loan provision. In conclusion, precision farming can be used to improve the quality of life of farmers as well as improving root crop production in the region.